All right, we're gonna do the first video for notes 3, and I'm gonna do the first 2 sections, which problem number 1 up here is a reminder about least common multiple, and then I'm gonna do adding and subtracting fractions in this video. I'll have separate videos for the rest of this note sheet. All right, so first part here, least common multiple, LCM. You pick your method. You figure out what makes sense to you, do that. I'm gonna show you both methods for this first part here. Let's say you're going to list out the multiples. So I want you to count by threes. 3, 6, 9, 12, 15, 18. I'm going to stop there. Maybe I need more. Maybe I don't. Let's see what happens if I count by fours. So 4, 8, 12, and I'm going to stop there because 12 is my least common multiple. That is the number that they both share there as a multiple. I can do the same thing for part B. If I count by twos, 2, 4, 6, 8, 10, 12, 14. I kind of, at a certain point, run out of steam. If I need to put more numbers up there, I will. I'm going to count by fives now. So 5, 10, 15. And actually, I already put too many up there because 10 is the common, least common multiple there. Okay? So next little part here, we've got 4 and 8. And for 4 and 8, I'm going to show the other method for doing that, which is to write out the factor tree. Okay. Now, if you're going, I don't want to write out a factor tree, I like writing out do that. And you might be able to look at this and say, I already know what the least common multiple is. That's fine too. Ultimately, I just need you to find a multiple here. All right, the least common multiple. So for 4, if I break this up, that's going to be 2 and 2. So 4 is 2 times 2. For 8, I've got 2 times 4. 4 can be broken out as 2 and 2. So for 8, I've got 3 2s. And for 4, I've got 2 2s. So for least common multiple, I need each factor to show up in my answer. Right? Each possible numeric factor show up in my answer, the maximum number of times it shows up in any single number. So what on earth? So I've got 2s, all right? So clearly I'm going to need a 2 as my least common, as part of my least common multiple. I wrote that really large, so I'm going to write that slightly smaller. And now how many 2s do I need? I need the maximum number that shows up in either of these values. Well, 2 2s show up in 4. Whereas 3 2s show up in 8. So I need the maximum, which is the 3 2s. That is going to be a least common multiple of 8. All right, and then last but not least, I've got 3 and I've got 5. Well, I can't break up a 3. It is a prime number. And I can't break up a 5. It's a prime number. So that means for my least common multiple, I need a single 3. And in a single 5, that's going to be an LCM of 15. Now, we did this in notes 2, a little bit of practice you've had with that already, but what you've just done is something you're going to need to have to figure out when you are adding or subtracting fractions. In order to add or subtract fractions, you have to have a common denominator. Your common denominator is the least common multiple of your 2 denominators or whatever amount of denominators you have. So part A here, we've got denominator of 3 and 4. Well, we already figured out that the least common multiple of 3 and 4 is 12. So I'm going to use that information. I'm going to make a little note to the side here, right? LCM is 12. So I'm going to do a rewrite for both of these fractions. A little plus sign here. And the question is, how do you get from 3 to 12? Well, you need to multiply by 4. What you do to the denominator to change that common denominator, you have to do that to the numerator to keep your fraction the same value. So 2 times 4 makes 8. That is very hard to read, apparently. And then we're going to do the same thing with the second fraction. How do you get from 4 to 12? Well, you multiply times 3. Do the same thing to the top. Now you've got 8 over 12, which could reduce to 2 over 3, plus 3 over 12, which could reduce to 1/4. So we have not changed the fractions. I mean, okay, we've changed the numbers of the fractions, but we haven't actually changed the value of the fractions. Then to add fractions, you are going to simply, I should say add or subtract, you're going to simply work with the numerators. 8 plus 3 makes 11. The denominator of 12 stays the same. So 2/3 plus 1/4 is the same thing as 11 over 12. All right, we're going to do the same thing for the rest of these problems. And I hope you recognize that you've actually already found the least common multiple for 5 and 2 in the previous part here, which is 10. Okay. So, again, I'm going to make a little note to self. So LCM is 10. So we need those two denominators to become 10s. Well, how do we do that? Well, we're going to take a 5 times 2, which means we need 3 times 2. That's 6 over 10. And then to get from 2 to 10, we're going to multiply by 5. So multiply by 5 top and bottom. That's going to be 5 over 10 there. So 6 over 10 minus 5 over 10 simply, not reduce, try again. Simply subtract, in this case, the two numerators. So 6 minus 5 is 1. Denominator of 10 stays the same. So that one is now done. 3/5 minus 1/2 is 1/10. All right, moving on to part C here. The LCM, or least common multiple, for 4 and 8 was 8. So I need a denominator of 8, denominator of 8. Now, this is kind of cool. This fraction already has a denominator of 8, so it is not going to change. The first fraction does have to change because it didn't have the right denominator. So to get from 4 to 8, got to multiply by 2. Means you're going to multiply that numerator times 2 as well. So 6 over 8 plus 1 over 8. Add the two numerators, 7 over a common denominator of 8. All right, last but not least, we're going to move on to part D here, which is, well, a mess. Here's the issue. We have what's called mixed fractions. And one of the easiest ways, I say easiest, but let me rephrase that. Probably the best way to deal with mixed fractions is to turn them improper and then deal with them. This way you don't have to try and borrow. Yes, you can borrow with fractions. It just becomes a big mess. So as far as 4 1/3 goes, we're going to take the whole number times the denominator and then add the numerator. So 4 times 3 makes 12. 12 plus 1 is 13 over 3. So 13 over 3 is the improper fraction equivalent to 4 1/3. We're going to do the exact same thing for 2 2/5. So whole number times the denominator, and then add on this numerator. So 2 times 5 is 10. 10 plus 2 makes 12 over 5. All right. You need a least common multiple for 3 and 5. So the LCM, we already knew this from the last part, is 15. All right, so that needs to become a 15. That needs to become a 15. All right, 3 times 5 makes 15, which means I've got to take 13 times 5. If you need to do the math off to the side, do the math off to the side. I'm going to do it in 2 parts. I'm going to take 5 times 10, which is 50. I'm going to take 5 times 3, which is 15. 50 plus 15 is a grand total of 65. Okay, and then I'm going to do 5 times 3 to get my 15, and then times by 3, do a little erasing there because that was horrible to read, and then 12 times 3. I can do the same thing I did in the last one. So 3 times 10 is 30, and then 3 times 2 is 6. 30 plus 6 is 36. So now that I've converted these mixed fractions to improper fractions having a common denominator, now, at the very end here, I can finally do the last part of the subtraction. So 15 is my common denominator. 65 minus 36. What I did in my head to actually figure this out is I did 65 minus 35. 65 minus 35 would be 30, and then I subtracted the extra 1 to get to a total of 36. So that's going to be 29. So all that hard work, and you get 29 over 15 for the answer to part D. All right, I'm going to pause here. Let me know if you have questions on finding least common multiple with any of the methods I've shown you, or if you have a different method. And then for adding and subtracting fractions, you have to have a common denominator, which means you might have to rewrite your fractions, which means you've got to get that LCM to do the rewrite and then do any kind of subtraction or addition that you have. All right, I'm going to close out this video, and then I'll do another video on multiplying and dividing fractions.